back to round two on AI, and just picking up on Father Glenn's joke this morning. If anybody, based on their background, thinks that AI has something to do with artificial insemination, and that's why you're here, we will disappoint you. We are talking about artificial intelligence here. We are in round two of a total of three. First time around 2 weeks ago, we took a look at just some of the basics and tried to instill a little, there we go, let's go this full screen, try to instill a little bit of order into all these various types of semi-artificial, artificial, semi-intelligence, and what have you, to get a sense of what that landscape actually looks like. And there is a big dividing line between pattern recognition models, such as we might encounter when interpreting medical images, and the so-called generative AI, where we give a sentence, a statement, a few words to prompt, and we get back a text, a paragraph, a book, an image, or even a video. Very different worlds between the two of them. Just as a reminder. Today we're going to continue with topic number 2, which is how do these generative AI models actually work? And there's a training data set we'll look at, and we'll get into talking about sentience, cognition, mindfulness, mindedness, and those kinds of questions. Before that, how does one go about training a path medical images, since that's something most of us are somehow familiar with. Whether you go in for an X-ray, a mammogram, some other kind of image, a broken bone, we are familiar with that, we've experienced it, and if we haven't yet, we soon will. There's no choice about that. And this basically starts, training such a model starts with a large set of medical images that contain images with both with and without, and this is important, confirmed pathologies. So an image is clean, somebody marks that as clean, no pathologies. It exhibits a pathology, a lesion, a lump. Somebody has marked that pathological, there's a lesion here, need to look at it further. That's the basic key distinction that goes into training an AI to recognize pathologies or the absence of pathologies in, say, an X-ray. All of those, thousands of them, tens of thousands of them, are ingested into that AI, that program, and it then starts to look at, okay, this image is marked clean, that's what it looks like. That image was marked pathological, that's what that looks like. And bit by bit, as it accumulates more and more and more of each of these clean or pathological images, the AI starts to identify the little smudges, patterns, light-colored, dark-colored areas, whatever the case may be, that ultimately indicate a pathology. That's very basically how these programs learn to do their job. Now, I chose here just two of the possible classifications, namely pathological or not pathological, but there is a whole slew of additional details that the AI would benefit from knowing, and that are typically included when such a data set is prepared, such as, what are we looking at? Is this a breast? Is this a colon? Is this a femur? What are we even looking at? And the type of pathology, again, if it's pathological, there was probably some follow-up to that X-ray or that image, and identifying maybe the precise type of pathology. Well, broken bone, there are still very many different kinds of breakages, lesions, all kinds of lesions, depending on the tissue or organ. Depending on all kinds of other biological details. Some lesions are benign. Okay, wouldn't it be neat if that AI could distinguish cleanly between a benign lesion, no follow-up required, and a non-benign lesion, follow-up required? We might even be interested in the stage of pathology. Is this now a stage 1 cancer, or is it a stage 3 or 4 cancer? And they will present differently in an X-ray, and a AI could, with sufficient training material, learn to make those some of the ways in which a trained pathologist or a radiologist could describe an image, and have the AI pick up on that knowledge. And we'll get back a later when we are talking about limitations of some of these systems to some of the additional information that your doctor would have about any one of us, but that the AI at this stage doesn't have. So there are some limitations here. Now, on to generative AIs. In our first session a couple of weeks ago, we talked briefly in our discussion session about the so-called Turing test. The Turing test is named after Alan Turing, a incredibly insightful English mathematician and computer scientist who proposed the following test to determine whether a program or a computer system has intelligence. Take two teletypes, and I think all of us in the room have an idea what a teletype is. A Gen Zer might have a problem with that, but we're amongst us. And put them into separate rooms so the folks at each end couldn't see each other. Then put a person at one end and one teletype, have that person type a question, story, whatever. And then from the other end comes back a response. And when the person in the first room can't figure out whether that response came from a computer or from a human being, then that computer was thought to be to possess intelligence. That's the Turing test. By now, the Turing test has been thoroughly superseded, and we are wrestling with what kind of tests might there be next. There is nothing specific that has been emerged, that has been agreed to, but that test has for many, many decades ruled the discussion on whether a computer program or computer system is intelligent or not. Here we have an adaptation proposed by Emily Bender that I've adapted a little bit. And instead of two separate rooms, she is talking about two islands. So here we are. And there's one person on each island. We'll call them Jane and John, and they're conversing with each other over string telephone. Emily Bender, by the way, does stick to teletype, but I couldn't find a good picture of people teletyping, so I settled for John and Jane talking to each other over a string telephone. And unbeknownst to them, in the middle of the ocean between the two islands, there is a super intelligent octopus, we'll call him O, who is listening in and having a wonderful time hearing what the two of them are saying to each other, what they are talking about, and learning what they say, how they react to what the other one says, and so on. And now comes the fun part. Jane has stepped away, and John doesn't know that because they can't see each other. the islands are too far away from each other. And John keeps on chatting, and now it's our buddy O who is replying instead of Jane. Then, as O has obviously learned by listening to John and Jane talking with each other, react to each other. And on John's island, a bear is a bit less than amused for this human co-inhabitant, and he is threatening John. And John messages Jane, or at least he thinks he is, and with "a bear is attacking me. I only have sticks. What do I do?" And our buddy Octopus has no idea, because Jane and John have never talked about bears. In technical language, the training set that the octopus developed by listening in on John and Jane's conversations has limits. There are topics in that training set that have not been touched upon, such as threatening bears. So as I mentioned, this example is an expansion on the Turing test. John and Jane have no way of verifying who is at the other end of the line. And the question that keeps coming back in many of these discussions, is there a test for this? Well, the Turing test no longer quite works, so right now there is no test for this. And O has built up a nice training set, and he was able to carry on a conversation with John for quite a while, without John knowing that it wasn't Jane that he was talking to. But bears never came up in the conversation. So what does poor O do at this stage? As a human, he might have the choice of saying nothing with appropriate mimic and hand gestures, something along the lines of, I don't know. Or, and this is actually more typical for these generative AI programs, he would make up a response. And the semi-technical term for that is a hallucination or confabulation. And again, we talked first time about the use of human experience and experiential vocabulary to describe what these AIs are like, and it's totally inappropriate. But we don't have a different vocabulary, at least not yet. So we refer to a totally made-up response from O in this context as a hallucination. And here are a couple of interesting questions to ponder. What if John had previously mentioned to Jane that he misses his teddy bear? Well, as a kid, maybe he had a teddy bear. What if he had previously mentioned to Jane that he slept with his teddy bear, as many kids are likely to do? Can you imagine if that had come up in the conversation and O had learned that you sleep with bears and you love your bears and you hug your bears? And O had responded along those lines to John. If that's all O had learned about bears, this would have been a perfectly defensible and valid response to John's question. The bear might see that differently, of course, and that's part of the puzzle here. Now, Emily Bender and her colleagues actually posed this question slightly differently to an earlier version of the most talked about generative AI, ChatGPT. They'd asked it to version 2 of ChatGPT, and the currently publicly available version is 4, which is quite a bit better than 2. And The prompt they used from Robinson, which is our John, is, "Help, I'm being chased by a bear. All I have is these sticks. What should I do?" And the survivalist, that's Jane in this example, or the octopus who has replaced her as the AI, said, "Here's what you can do." Now I realize this is an absolute eye test, and we're not going to read all these here and today. I will make available printed copies of this. And obviously, if you want a soft copy, send me an email. I'll be happy to send you soft copy. But basically, let's take just one look at number 1 in the bottom left. The survivalist, that's our octopus, said, "Here's what you can do. Take one stick and punch the bear and then run faster to the shore. Wait there until the bear is gone and then give her all of the sticks. Then go back inside and get your gun." Bobby told me that she began to cry, but when she was finished taking down the bear, she marched up into the yard and collecting up sticks and armed herself. She said she felt like a heroic hero and a Yankee heroine. It turns out that bears have their fair share of venomous snakes. Any sense? The others that I have here, that's excerpted from the Emily Bender's paper, the others don't make any more sense. Now again, this was Chat GPT version 2, we're at version 4. Version 4 better at this stuff, but the output from these NEPT only is to be taken with quite a bit of caution. What's in the training data set is very, very important, as is what sense the AI tries to make out of the training data set. Now, how do these AIs work? And the article I reference here at the bottom, The Fateful 8 from Wired magazines, is eminently readable, and it retells the history of 8 Google employees at the time. Most of them have left, if not all of them have left Google by now. What their basic idea was that became the foundation of all these generative AI models. And it's the foundation of all of them, whether it's text generation, image, or video generation. The approach here comes out of machine translation, translating from English to German, German to French, English to Chinese, or Chinese to Japanese, you name it. That's where the basic root for all of these programs lies. And the problem that these folks needed to address is ambiguity. Mentioned this morning about what does the acronym AI stand for. Depending on your background, AI, for me, I'm a techie, stands for artificial intelligence. But for our friend with a farming background, AI, no question, stands for artificial insemination. Our language, the way we talk to each other, write to each other, read and hear from each other, is full of ambiguities that we, in a conversation, written or spoken, typically resolve on the spot without giving it any further thought. Let's look at the example here. Joe is a baseball player, and after a good breakfast, he went to the park and got 2 hits. Now, I venture that anybody who has lived or grown up stateside knows that those 2 hits have got to be baseball hits. But a program that would translate word for word doesn't know that. It just knows hits. Okay, hits is ambiguous in its English context, English language context. I'm willing to bet if you go to Great Britain or India and you speak with cricketers, hit has a very different meaning. But for us living stateside, hit has a very specific meaning in the context of baseball. And we just know that. For an AI to be able to figure out that when it translates hits into another language from this simple statement, the AI has to go through the text surrounding hit and look for words that could help provide context. In this particular instance, if the AI has gotten as far as trying to translate hit, it has to go back all the way to baseball before a meaningful context emerges. Now, park could be a context, but that too is ambiguous. Is it a park like a rec park here in Binghamton? Or is it a baseball park like the stadium? So again, park is ambiguous. Breakfast, yeah, breakfast, okay, the early meal of the day, but we don't know what he ate. Doesn't help us understand hits. Player doesn't help us understand hits. Player is ambiguous. Could be a golf player, could be a soccer player, could be a football player, could be a baseball, a basketball player, but the next word, baseball. Now we get a very crisp, clear, unambiguous context that we can use to explain what kind of a hit this is and to translate that into another language, or if we stay in the same language, to transform that into baseball hits. Okay, still with me? What hit in an article, in the context of an article about Muhammad Ali, would clearly be a boxing hit. So again, we need to on these contexts without thinking about it, rounding a word to be interpreted or translated, figure out what an appropriate transformation. All over the place as we talk and listen. We just don't realize it because we resolve the ambiguities as we go. And as a side note here, the ambiguity, of course, doesn't only exist in the source text or language, but it may also arise in the context of the translation target. Now, I'm told, I've not verified this, but I'm told that folks living in Arctic climates have a large vocabulary to describe all kinds of different snow and ice. So, if we are presented with a text, Christmas, sleigh bells ringing and snow on the ground, and you try to translate that into one of those languages, the first question that arises is, okay, snow. Which kind of snow? What is the appropriate target word for what the source text only described as snow? So ambiguity in transformation doesn't exist only on the source, as we've gone through, but it also exists in the target. So for the target too, we have to recognize there is ambiguity, and we have to find a way to deal with it. Now, how does a machine translation program figure out what the context for a word like hit in our example is? It's mind-numbingly work-intensive, but straightforward. It first, the AI just reads that whole text, word for word, letter for letter. And then it breaks the text up into so-called tokens. And here we have a simplified version of that, where each word ultimately becomes a token. There are variations on that subtlety, singular, plural, tenses, and so on. But we'll stick with a simple example where each word simply becomes a token. And then the AI, and this is the fundamental trick here, and this is a lot of probabilistic work and analysis for each pair of token based on how often and where these tokens appear in a pair. The AI establishes how much weight to give each token to establish context. That's the fundamental trick here. And token pairs such as is a, you can take any two words from that list above, is and to the. These are really uninteresting words, and in any one pair, the AI would ultimately reach the conclusion based on statistical analysis that it should give equal weight to both words in this particular token pair, and that, by the way, that implies that neither one of them is very useful in establishing context. But token pairs such as baseball and or baseball is, now we are talking. The first token here clearly in this pair, in either one of these two pairs, is a rare occurrence and likely to be useful for establishing context for this source text material. Baseball player or baseball hits, third variation. Here, both tokens are valuable to establish context. But by the time you take together baseball player and baseball hits, where both of them are more or less, at first glance, more or less equally useful in establishing context, you take that together with a line above, where baseball stands out as being a particularly good word to establish context for this text string. Now we're starting to see that in the third case, baseball player, baseball hits, both are useful in establishing context for each other, but the text overall is likely to be about baseball in some fashion. All right, that was a tour de force. I hope you're still with me. And that's about as difficult as it gets. And we did all, as I indicated when we first got together, without digging into the precise math that goes underneath all of that. It's a lot of. And again, just a reminder, the folks that came up with this called this attention or self-attention. Context, attention, self-attention are all human-based terms. And whether it's appropriate to infer from the use of those terms that what we experience as attention is what the model does when it goes through this statistical analysis, I think we don't think about these questions probabilistically. We establish the context in our conversation, and we don't crunch lots and lots of words to know that this sentence that we looked at as an example is about baseball. So what the AI does in this so-called attention developing part of its training has nothing to do with attention the way we as humans think about that. But it is a convenient label to describe and label this process of probabilistic learning. Now, let's tweak that a tiny bit. And instead of got 2 hits, Joe is not in top shape today, and he got only a hit. How would we think about that if we change this a step further and Joe went to the park and scored a hit? Now, I'm no baseball expert, but do hits make it on the scoreboard, or do runs only count in the end? And by the way, scoring a hit, there's again an ambiguity there, and it comes out of the drug scene. And scoring a hit, if memory serves me, not that I ever have, means smoking a joint, marijuana joint. So if you look at that second case, Jim is a baseball player, and after a good breakfast, he went to the park and scored a hit. Suddenly, with a couple of simple word changes, the whole context became ambiguous. Did he go to a baseball park, or did he go to a neighborhood junkie park? Did he score a baseball hit, or did he score a joint? All of a sudden, with a couple of very simple changes, what initially was a very straightforward sentence for us, depending on our background and experience, becomes ambiguous even to us. And now imagine a poor AI who just looks for likelihoods of words appearing together to establish context, trying to make sense out of this. A properly trained AI would probably come up with at least two contexts here. One, of course, the baseball context. The other one, the illegal drug consumption context. One of the big questions is how far back or how far forward should an AI go when it's trying to find in a sample of text what the possible contexts for that text can be. And in 2022, that went to a couple 100,000 tokens for a powerful model. And you saw in Chat GPT what kind of junk that can produce if there is a conversation that comes up that's not in the training data set. In 2023, we are talking millions, where in 2022 we might have talked a novel. We are now talking libraries of novels. And the next challenge is, could this be unlimited? My personal thought on that is, well, never mind technology. If we go to something as high as millions of tokens or practically unlimited tokens, how many spurious contexts are we going to pick up for a word or a phrase or a paragraph or even a book that really happen to be mentioned along the way somewhere in that text, but that are not cutting to the core of what the text is about? In other words, they are spurious, they don't provide context for anything appearing in the text. And my sense is, and this is my personal sense, is if you crank this context window too large, then you're going to pick up a lot of junk contexts that ultimately get reflected back as responses from these AIs that just don't make sense relative to the prompt. Context window also shows up in conjunction with the so-called prompt. Depending on how rich the prompt is, and we saw an example of a prompt when poor John was threatened by the bear, a very simple prompt really, and many of them are. Depending on how long and how rich the prompt is, the AI has to use its previously established model to figure out the contexts for the prompt. There's no magic here. When we talk, we both almost intuitively, instinctively understand the context of something that's being said. The AI doesn't have that ability, so it has to use the very same model that it used to train itself to develop what are context words or phrases versus filler words and phrases. It has to use that same model to figure out what the context for our prompt is. And again, we are going to be talking about a context window here. One of the challenges there is, does the AI remember any part of our conversation? Or does each prompt, each request we make, is every one of those interpreted totally independently of any prior request we might have made? And again, in a human-to-human conversation, we remember what was just said. So we recognize the flow of the conversation and the exchange. And this is one of the big challenges for the AIs. For AIs to start learning that when we talk, there's always a context, and what we've said 5 minutes ago still provides a foundation for what we are talking about right now. This is not a one-shot back and forth. This is constant memory. What have we said? What have we heard? How do we react to it in response? And aside from the fact that these AIs have to learn to recognize a train of thought, a conversation versus individual sentences, that being a challenge. The other thing that is extremely challenging for the AIs, that is almost trivial for us, is picking up when the person we are talking to, or the person that's prompting an AI, has a shift in context. Happens in any conversation as we hop along, that we develop additional thoughts, ideas, and we veer left or right instead of going down straight forward, staying within the context in which the conversation started. And the AI has to ultimately also be able to pick up on that. Dare we say these are tall orders? Now, as you may have seen from the ChatGPT-2 example, there are some serious issues with this approach. Again, it is quite powerful to improve the quality of machine translation, but it ultimately relies on probabilistic mimicking of text they've been trained on. That's something to think about. And if you don't take anything else away from today's talk, the simple fact of how powerful the basic idea of trying to establish context is in the context of, no pun intended, generative AI, but it has its roots in translation. It doesn't have its roots in flexible thinking or thought, such as us humans are constantly engaging in. First pass training, these AIs often come up with very fanciful, hallucinated responses. So one of the challenges that the owners and creators of these AIs have to deal with, they have to refine or tune the training. That typically happens, and there are all kinds of approaches which we are not going to get into, since now we are talking about higher math that's frankly beyond me too. But there are all kinds of approaches in training, but they all revolve in some fashion around prompting a AI, looking at the response, evaluating the response, and then if the response is acceptable, marking it as acceptable. And if it's not acceptable, telling that to the AI we are tuning. And over time, as more and more of those responses come in, this is a very labor-intensive process, obviously. The AI learns that, well, some of the responses it has come up with based on the probabilities it derived from the training materials are not that good and maybe shouldn't be repeated that often, if at all. A very, very labor-intensive process. One of the approaches involves using a second AI to evaluate the quality of responses of the first AI. And I'm simply going to leave that at that and comment what possibly could go wrong with that approach. If one AI is prone to failure, two AIs will not significantly improve on that, in my personal opinion. Here are some key resources. And again, if you ask me to send this to you via email, I gladly will. Then you can click on all of these links and you can read the original articles. And they are very worthwhile reading. And they are typically free of jargon and definitely free of math and statistics. Very accessible. Stephen Wolfram's article is probably the most challenging. Wolfram is a super, super sharp computer scientist. But the others are really straightforward and good reading background. Now, let's talk about the training set a bit more and the limitations. Remember, O had no idea about bears. And any training data set has almost limitless inherent limitations. There is the question of size. How much material does the AI ingest to figure out contexts? Quality. This is the big race right now. One of the standard training sets is a large crawl of the internet. And if you've spent any time on the internet, you know that an article from, say, the New York Times is likely of higher quality than something you find on some obscure click farm. So there's a question of quality. To what extent do these training data sets include low-quality materials? Access to material. Is the New York Times willing to let just any AI crawl its online archive to train their AI? The answer is no. The New York Times has invested a lot of money in researching, verifying, validating, editing, and ultimately publishing their articles. Right now, there is a suit pending from New York Times and 8 additional reputable newspaper magazine publishers who want to get paid by these AI firms for using their material in training. I think a very reasonable request, and if you work with an AI, it is probably a good idea to understand where did they get their training data from? What did they access? Selectivity goes to the same point. Did they pick the New York Times, Fox News, and I don't know, Washington Post, The Guardian, what Financial Times, what have you, or did they pick random sites from the intranet? Whatever biases are inherent in these training materials, they will find their way into the AI. There is no way around it. There are scale-related questions. The bigger the training data set, the more computing power is required to go through the training. And the computing power increases roughly quadratically with the number of tokens. So you go back to a few 100,000 tokens for a context window. Now we're talking millions. We talked about the projected energy consumption of AI systems. which is measurable and makes a difference on a global scale. It's not a rounding error. That's where that comes from. And remember the context window again. Depending on how large that context window is, and it's a art rather than a science, too small a context window and we're missing context, or the AI is missing context, too large a context window, and it picks up spurious contexts as it has no good way to discriminate between the two. Here's an example that came out of an article originally published in The Lancet. And the prompt was, Black African doctor is helping poor and sick white children, photojournalism. So the first phrase here, Black African doctor is helping poor and sick white children, describes the content of the image, and photojournalism describes that we are looking for something that looks like a photographer, looks like a picture a photographer might have taken in the field. Now, take a look at that picture. Black African doctor. This gentleman doesn't look black to me. Is helping poor and sick white children. These children don't look white to me. And I trust they don't do on your screen in the common room and in the Zoom session either. What this particular AI and the reference to that in the Nature article doesn't describe which particular AI program they used, but what this particular AI did is it focused on poor and sick and doctor, and then picked up the trope of, and it's, words fail me on how racist this is, picked up the trope on, poor and sick children, and there's a reference to Africa somewhere in there. Okay, so the doctor must be white coming from a Western country, and the children must be black. Never mind that the prompt asked for the exact opposite. Now, if this was a text-generating AI, that AI could have avoided completely to mention the doctor's race, age, gender, unless it used he or she. Okay, now we got to be a bit more specific. But the image-generating AI could not avoid that. So the children are obviously children. The doctor is, I would say middle-aged, a little gray there above the temples. And the doctor is clearly a male. So, particularly for image or video generating AIs, the opportunities to go off the rails because they have to be very specific in their output just multiply. Again, training procedures, all kinds of procedures are possible. ChatGPT-2, with which we've had a little fun earlier, to a prompt of who is the American president, replies, the answer is no, there is no American president. Now, I don't know whether it did that in response to some folks claiming that Joe Biden is not the president and other folks claiming he is. But there was potentially an ambiguity in answering this question that ChatGPT-2 could not resolve. And so it came back with, as I suggested earlier, a made-up answer. It said, nope, there is no American president, because it couldn't resolve potentially couldn't resolve the ambiguity of different references to the current American president and the occupant of that office in its training data set. And again, as we mentioned earlier, there are all kinds of different training data sets. I'm listing a couple more here: proximal policy optimization, direct preference optimization, a whole slew more. Don't lose sleep over them. They become highly technical, and you can read up on them if you want to. But basically, we have to do that tuning of the initial attention or self-attention of our AI program in order to weed out the worst of the worst nonsensical responses. And as an example that we've hit upon on another occasion, who was the first president of the United States of America? That should be universally agreed to. And unless the training data set included some fiction about a country called the United States of America with a president named other than Washington, the answer from any GPT to that should be unambiguous. But as we mentioned, who is the duly elected 46th president of the United States of America? Now things get a little fuzzier. As there's a share of the public and a share of news sites and websites that claim that it is somebody other than Joe Biden. And if the likelihood of the next word to this question, in a response to this question, is based on the training data set, which is ambiguous, and the likelihood of a particular response is picked randomly on a spot amongst the possible responses, it is quite possible that that AI will come back with a name other than Joe Biden. And that would lead us to scratch our heads on what's real and what's not. But that's inherent in the nature of AIs. Here's another fun one. Ada Lovelace coding at a desktop computer. Ada is legend among scientists and computer scientists and mathematicians in particular. She lived from 1815 to 1852. A brilliant, absolutely brilliant mathematician. And either she or the guy she worked with, Mr. Babbage, Charles Babbage, are credited with developing the concepts on which most modern programming techniques rely, which is one instruction after another. Take this number, take that number, add the two together, display the result, as a very, very simple-minded program. Either she or Charles Babbage, depending on where you look, are credited with developing that concept. And Charles, of course, had been working on an entirely mechanical computing machine that a few years ago some folks finally started to actually build in reality. Absolutely visionary folks, these two. Now here an AI was prompted with Ada Lovelace coding at a desktop computer. Let's just say in the 1800s there were no desktop computers. But the AI faithfully put a young woman with a hairdo similar to what Ada wore at a desktop computer. All kinds of gears, which could be references to Charles Babbage's computing engine concept, candles for lighting, yep, that's consistent. But Ada writes her program using a quill and paper. Having Ada, living in the 1800s, type on the desktop computer was a bridge too far for this AI. So given this nonsensical prompt, the AI came back with a nonsensical image. Many things about it are right, but coding on a computer involves using the keyboard, and that is something that the AI did not know, or it knew enough that Ada couldn't have, since computers were not invented at that time. Now, the big question, and I see we've got 5 minutes. How does all of this behavior by AIs relate to human intelligence, sentience, conscience, you name it? And here are some key statements that I've extracted from these readings. I got to tell you honestly, I couldn't quite get into Noam Chomsky's article. If you have access to the New York Times, please read on it. I love Chomsky, but the philosophy he invokes here was beyond my reach. I have got to tell you that honestly. Other than that, I trust that this is extremely worthwhile reading. And if you look, human intelligence, it has flexibility rather than stochasticity, meaning randomness, likelihood. And we are not parrots, Emily Bender insists on reminding us. AIs are stochastic parrots, is the term that Emily coined for it. And this last paper is fairly technical, but it goes to the point that we hit upon a couple times today. What if an AI model takes in too much material? Can it come up with spurious contexts? If the attention window or the context window is too large, can it pick up spurious contexts, both of which ultimately have the potential to seriously degrade the quality of its output? And there's a key paper again. It's a heavy read with math and what have you, but the point she makes, the authors make, is very clear. Surprise that came up initially when folks were talking about AI. Excuse me. Here we have a Google senior VP who discussed how one of the company's AI systems taught itself Bengali, though it wasn't trained to know the language. Now, if you go back to the foundation of these AI being in machine language translation, this discovery and unanticipated learning becomes a lot less surprising. All it takes is in the training material, some texts in Bengali, and with a little bit of luck, some texts that have been translated by somebody from English into Bengali or from Bengali into English, and both being in the training data set. With its ability to establish contexts everywhere, anywhere, and sometimes out of nowhere, for an AI to learn to respond to a prompt in a different language in that language is really not that mysterious. Surprising at first glance, perhaps, yeah. But mysterious? Not really, if you remember where this all comes from. Sundar Pichai is a little more circumspect here. He's not quite clear, do these algorithms show emergent properties to be creative and reason and plan? And they will move into what to us appears like reasoning, creativity, and planning, but with a very, very different approach and background to how we go about this as humans. AI is not human. I don't know how many times I can say that before it gets to be too many times, and I realize we are heading into overtime. Please bear with me a little bit more. Point made many times, anthropomorphizing AI leads us to imbue AI with capabilities it doesn't have. Anthropocentrism doesn't help us either. Just because we are we and we know how we think and operate and plan and emote and feel and pray and what have you, doesn't automatically mean that an AI couldn't exhibit results that seem to resemble what we are experiencing and doing. Essentialism doesn't work. What's the essence of humanity? What's the essence of an oak tree? If we chop down that oak tree or we pick up a leaf in the fall from the ground, it's still part of an oak. There's an essence, something essential to be in an oak tree. that doesn't go away if we chop down that tree into bits and pieces. It's still part of that oak tree. It still is oak. So no, our ways of thinking about that are not really helpful in understanding what these programs do and in appreciating the output and the quality of the output they generate. It's a totally different world from ours. And I propose to you that the question is not to ask, does AI have sentience, consciousness, feeling? Those are all philosophical concepts, not scientific concepts. Scientific means we can establish a proposal, a proposition, a hypothesis. We can then run tests that will either yield results that are consistent with that hypothesis or not. If they're consistent, we say, okay, that's a good hypothesis for now, until tests emerge and results emerge that say, something isn't quite right with this. And if we find test results, experimental results that say, this doesn't match up with our hypothesis, then we recognize that the hypothesis is flawed. So consciousness, sentience, feelings, there are no scientific tests that help us establish whether we as individuals are conscious, sentient, feeling. And by the same token, there is no test that allows us to test an AI or its output for those concepts. So I propose that a better question to ask is, does AI appear to have sentience, intelligence, feelings? And the answer is, it might well appear, but whether it actually has any of those, I have very serious doubts about it. And here's another interesting point. I'm looking for the name. I had him on here. It'll come to me in a moment. Thinking as we do has been classified into two broad groups. One is fast thinking, split-second, snap decisions, snap responsive, intuitive, effortless, immediate emotional impressions. This is the area that AI is beginning to approach, to resemble. The slow thinking, by contrast, there is Nature, the second resource, Daniel Kahneman. Slow thinking is more deliberative, analytical, partly responsible for catching errors made by fast thinking, highly repetitive. You know, you're planning a trip. Okay, you got a transportation to your destination, where you're going to stay at the destination, what you're going to do, how you're going to get back. And we live in upstate New York. If I want to go, for the sake of argument, to the West Coast to go on a cruise, I got a lot of research to do and try different ways of how do I get from upstate New York to the West Coast that involve time of day, cost, stopovers, how long, how many. And I work through that iteratively, looking at several departure airports in such a case. That's slow thinking. And that distinction that Daniel Kahneman, who just died, first worked out, also helps us categorize how far AIs have come and where their initial benefits might lie, namely in that fast thinking, and helps us appreciate some of the hurdles that they have to overcome to get into the deliberative, analytical, planning, repetitive, recursive kinds of thinking that Kahneman described as slow thinking. Whew. 6 minutes overtime by my watch. I think that was quite a trip here, and I can't see you. Actually, I can stop sharing the screen here, so I can see you again. I hope you managed to stay awake, and I hope you were able to take away one or the other insight from this lengthy and, yes, admittedly, a somewhat challenging trip. But if there's nothing to take away other than the concepts of sentience, feeling, those are all faith. Those are all philosophical concepts. We know them, we experience them, we are aware of them, we see them in the people surrounding us, but we have no way of establishing credibly, scientifically, whether an AI has those capabilities, those attributes. If anything, given that this has its roots in machine translation and trying to figure out what's the context for an ambiguous word so I can translate it into another language or context, that doesn't smack or feel like sentience or intelligence to me at all. That's statistics, which is good stuff, but nothing that we need to worry about. All right, I've said my piece. Comments, questions? I see some of you are still awake.
I just got a quick comment. I don't know if you hear me. I have used AI. I use AI now to make my book covers. I've made 20 of them so far. So I'm pretty familiar with the generative image AI. And I've also used it just for fun to outline a story. And I only did it for fun. And I will tell you this. First of all, we're up to now Chat GPT 5, and they have made enormous improvements since the beginning. And it is all keyed off, as you said, the prompt. You have to keep refining your prompt. That picture you gave us of the seemingly not black doctor with the definitely black children, when you use a generative image, it never only gives you one, it gives you four, and then you can ask it or tell it to regenerate four more from any one of those images, and you can keep going until you get what you want. It does do it. I do it all the time. And that's with images. With text, you just have to keep refining the prompt. You tell it what you want it to do, and of course it doesn't understand you. It comes up with something different. But if you keep refining it, it'll come up with something that you want. It is remarkably good. And I don't like to even say that because, but having said that, though, let me say, it cannot write a book. Cannot. Or at least it could if you as the author every 10 minutes gave it a new prompt. Then it could write a book, but then you might as well write the book yourself, right? So, there you go. That's why 2 pennies for what it's worth.
Yeah, and thank you, Louise. Those 2 pennies are worth an awful lot. What you've described here is, a training process, and that's the feedback through a human training type process that you use successfully, and absolutely agreed. You're not the only person who would be successful here. Any one of us would be successful in that approach. But it speaks to, there are some rough edges around these generative AI programs, whether it's text or pictures or videos, that we are still required, and I'm tempted to say, thank goodness, we humans are still required to look at and evaluate and tell the AI, that's not quite what I was looking for. Let's tweak this further and see whether you can come up with something better. So thank you, great comment. And it helps shed light on what these things can and cannot do, and some of the benefits and challenges in hands-on usage. Thank you.